awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Hai semua, jadi hari ini kita nak sambung berkenaan dengan electric field. Okay, so jom kita tengok that electric field is defined as a region of space around isolated charge. So kita ada isolated charge, kita ada region of space around the isolated charge where an electric force is experienced if a positive test charge placed in that region. Okay, so kalau kita ada positive test charge and kita letak pada region around the isolated charge tadi, so the positive charge will experience electric force. Alright, atau secara ringkasnya, electric field is a region of space in which an electric charge feels a force. Okay? Contoh di sini, we have a point charge Q, and this is a positive charge. And always remember, if we have positive point charge here, the direction of the electric field untuk charge positif mesti keluar, which is outward from the charge as shown in the figure. Okay, so the lines must be point radially outward from the charge, remember. And then here we have a positive test charge, and let's say we put a positive test charge of 1 coulomb in this region, okay, at point A for example. So this positive test charge will feel a force F, which is equal to 20 Newton. So kalau kita tengok dekat sini, point charge kita positif dan test charge kita positif. Kita ambil test charge, kita letak pada kawasan yang ada electric field. What happened? The test charge will feel a force which is to the right. F equal to 20 Newton. Ni contoh saja. Okay. So maknanya direction of the force on the test charge tadi at point A mestilah ke kanan sebab positif dan positif mesti repel one another. Remember. So the electric field strength at a point, for example here we have point A, we can calculate by using equation E equal to F over Q naught, where Q naught is the test charge. Alright? So based on this equation, the electric field strength at a point is defined as the electrostatic force per unit positive charge that act at that point in the same direction as the force. Okay? So maksudnya dekat sini, for this example, the direction of the electric field E is actually same direction as the force F. Okay? Kedua-duanya at point A, E ke kanan, F pun ke kanan. Okay? So based on the example, let's say F is equal to 20 Newton and given that Q naught is 1 coulomb, so actually we can calculate what is the strength of the electric field at point A, where EA is equal to 20 over 1 and it is equal to 20 Newton per coulomb. So remember, the unit of the electric field strength is Newton per coulomb. So you can see here that the direction of the electric field and electric force at point A is the same direction. And how if we put the test charge closer to the point charge at point B? You can see here that the electric field strength at point B is bigger than point A. For example here, the electric field at point B is equal to 40 Newton per coulomb. So remember, semakin dekat dengan point charge, for example here, B lagi dekat daripada A kan? So the electric field at point B must be bigger than electric field at point A. Alright? So here let's say we have another charge and this time we have negative charge. And look at here that the lines of the electric field for the negative charge must be pointed radially inward to the charge. And as we have discussed before, let's say we have a test charge at point A where the magnitude is positive 1 coulomb. And here you can see that the direction of the electrostatic force on that test charge at point A is to the left. Okay, sebab negatif dengan positif, so dia akan attract one another. So means that the direction of the electrostatic force on the test charge at point A must be towards capital Q. Dia mesti tertarik ke arah negative charge. So based on definition, you can see here that the direction of the electrostatic force and the electrostatic field here also the same, which is to the left. So now let's try to derive the equation. So since we already know that electrostatic force F is equal to KQ1 Q2 over R squared. So based on this diagram, here we have two charges, which is capital Q and Q0, di mana capital Q is the point charge and Q0 is the test charge. So when we try to substitute the formula of F, which is KQ Q0 over R squared, so actually here we can cancel Q0, and finally another equation for electric field strength is equal to KQ over R squared. Tengok betul-betul dekat sini, Q kita dekat sini adalah capital Q, where capital Q is referring to the magnitude of a point charge, not the magnitude of a test charge. Remember. And another important things that you must remember, that R is the distance between a point and a point charge. Contoh macam tadi, R itu adalah jarak antara point A dan juga point charge capital Q. Okay? Alright, so now let's move to another part. So here we have a properties of electric field lines. Alright, so now look at the first point where the lines always begin on positive charges and end on negative charges. So based on this diagram, you can see here that positive charge, the electric field lines always outward, radially outward from the charge, while for the negative charge, the electric field lines must be radially inward to the negative charge. Okay, so for the second point, the field lines must be tangent to the direction of the field at any point. So kalau kita nak lukis the direction of the field at any point, it is must be tangent to the field lines tadi. Okay? And the next point is the closeness of the lines indicates the strength of the field. Jadi kalau kita tengok dalam contoh ini, kita ada dua kawasan. So kawasan yang saya bulatkan dengan warna biru dan warna hijau. Di mana kawasan yang saya bulatkan dengan warna biru itu, the electric field is stronger. Kenapa? Sebab the lines between the electric field lines tadi lebih rapat berbanding dengan kawasan yang warna hijau di sebelah kiri awak. Okay, so kita boleh katakan the electric field strength dekat kawasan yang saya bulatkan dengan warna biru itu lebih kuat berbanding dengan electric field strength pada kawasan yang saya bulatkan dengan warna hijau tadi. Boleh? Okay, so point yang seterusnya, the lines never across. So when you draw the field lines between two charges as shown in the figure, pastikan garisan electric field itu tidak boleh bersilang ataupun bersentuhan. Okay. Alright, so sekarang kita cuba satu example untuk fahamkan berkenaan dengan soalan electric field. So here we have a question about the direction of the net electric field. Okay, so what is the direction of the net electric field at point C if the two charges have equal magnitude? So Q1 is positive charge and Q2 is negative charge. Both charges have equal magnitude, maknanya nilai dia sama. Kalau Q1 1 coulomb, Q2 also 1 coulomb. Okay, so look at point C. So kita ada point C di tengah-tengah itu. So here you can see that the electric field lines for Q2 must be radially inward. Okay, direction dia mesti betul. Okay, so sekarang kita nak tentukan direction of the net electric field at point C. So berdasarkan Q2, since the direction of the electric field line dia adalah inward, so we can see here that at point C, the direction of the electric field due to charge 2, which is Q2, must be to the right. Okay, sebab dia inward kan, dia masuk ke dalam charge tersebut. So maknanya kalau kita lukis besar, electric field tu you lukis besar, so you akan nampak at point C, the direction of the electric field due to second charge must be to the right as shown in the figure. Tapi berbeza dengan charge 1, di mana charge 1 adalah positive charge. That means electric field daripada Q1 tadi mesti outward. Okay, dia besar lah. Okay, seperti garisan hitam yang saya lukiskan. So that at point C, the electric field at point C due to charge 1, Q1, will be to the right. So awak boleh nampak daripada electric field lines of Q1, so all the lines is outward. Okay, so electric field yang akan kena pada point C itu juga adalah ke arah kanan. Okay, so if you want to determine the direction of the net electric field at point C, since kedua-duanya EC2 ke kanan dan EC1 juga ke kanan, therefore the direction of the net electric field at point C pun ke kanan, iaitu to the right. Boleh? Direction ni penting ya, sebab bila kita jawab soalan electric field, you mesti tahu direction dia ke arah mana. Okay? So now let's try to proceed with this question. Let's say given that Q1 is 3 microcoulomb while Q2 is negative 3 microcoulomb. And it is also given that the distance between point C dengan Q2 adalah 1 meter and the distance between point C and Q1 also 1 meter. Okay, so based on this information, kita boleh kira the net electric field at point C, EC equal to EC1 plus EC2. Okay, kita tulis dulu. And then remember that general equation for electric field due to the point charge is equal to KQ over R squared. So kita ada dua point charge kita, Q1 and Q2. So kita boleh kira lah EC1 equal to KQ1 over R1 squared plus KQ2 over R2 squared. And both value of EC1 and EC2 kedua-duanya adalah positive value kerana direction mereka ke kanan. Okay, ingat ya, bila you kira electrostatic force and electric field, dalam calculation kalau you ada negative charge, contoh macam Q2 tadi, okay, please make sure you ignore the negative sign of the charge. Remember, okay, so dalam calculation mesti ignore negative charge untuk Q2 tadi. Okay, so sebab apa? Sebab kita dah tentukan direction dia tadi. Okay, so dua perkara penting yang you kena ingat dalam calculation electric field and electrostatic force. First kali you must draw the direction of E and F based on the sign of the charge. Tengok the positive negative tadi. And then second point, dalam calculation Q2 is negative charge, make sure you tidak masukkan negative charge dalam you punya calculation. Alright? Sebab kita dah consider dia punya direction. Okay? So final answer for the resultant electric field at point C is equal to 5.4 times 10 power of 4 Newton per coulomb. Since the answer is positive answer, so the direction is to the right. Next, we move to the second example. Okay, so here we have Q1 and Q2 sama macam tadi. Cuma kali ini kita nak tentukan the net electric field at point A and point B. Okay, so given that Q1 and Q2 is same magnitude but the charge is positive and negative. So, kita mulakan dengan net electric field at point B dahulu. Okay, kita tengok pada lukisan kita. Okay, so at point B, the direction of the electric field at point B due to charge 2. Kita tulis sebagai EB2. So, kita nampak dekat situ, charge 2 kita adalah negative charge and electric field dia adalah inward. So, at point B, the direction of the electric field due to charge 2 must be to the left. Okay, and then for positive charge, Okay, you tengok line yang warna hitam itu adalah electric field lines. And Q1 is positive charge. So the electric field lines untuk Q1 adalah outward. Keluar kan? Keluar daripada charge. Therefore, the electric field at point B due to charge Q1. Nah, awak panjangkan garisan hitam tu. So, you akan nampak that the direction of the electric field lines at point B due to charge 1 should be to the right. Okay? Sebab dia outward tadi. So, sekarang kita ada dua direction. Satu ke kanan, satu ke kiri. So, bila kita nak kira the net electric field at point B, we must draw the direction where EB2 is to the left and EB1 is to the right. Okay? So, kita lukis macam inilah supaya kita nampak ada dua direction yang berbeza. And this is very important bila kita kira the net electric field at point B. Okay? Jadi, electric field yang ke arah kiri, you kena letak negatif. Electric field yang ke arah kanan adalah positif. So, EB is equal to EB1 plus negative EB2. Negative because the direction of EB2 is to the left. Okay? So, remember, jangan masukkan negative sign of charge Q2. Okay? So, negatif tadi untuk direction of EB2. So, dalam you punya substitution untuk nilai Q2, jangan you tambah lagi negative 3. Boleh? And then, after calculation, the total electric field at point B is equal to negative 6.48 times 10 power of 3 Newton per Coulomb. And since the answer is negative, means that the direction of the net electric field at point B is to the left. Next, we proceed to the net electric field at point A. Alright, so at point A, kita lukis dulu direction of the electric field at point A due to charge 1. Okay, sebab dia outward tadi kan. So, EA1 mestilah keluar lah. Okay, ke arah yang seperti ditunjukkan dalam rajah. And then electric field lines at point A due to charge 2, EA2, mestilah ke arah Q2. Since the electric field untuk negative charge, dia adalah inward. Okay, so kita dapatlah arah seperti yang ditunjukkan oleh arrow yang berwarna merah. So now look at here, we have two direction, EA1, and then we have another direction of the electric field, EA2. Okay, sepatutnya situ adalah EA, EA1 and EA2. Okay, jadi berdasarkan gambar rajah yang diberi, kita boleh nampak yang jarak antara point A dengan charge 1 sama dengan jarak antara point A dengan charge 2. Okay, soalan dah bagi tu 4 meter, 3 meter. So, we can calculate the distance between point A and Q1 and also point A and Q2. Jadi, dekat sini kita boleh nampak point yang pertama, jarak antara point A dengan charge 1 is actually equal to jarak antara point A dengan charge 2. So, soalan dah bagi 4 meter, 3 meter. And then we can calculate the distance between point A and Q1 is actually 5 meter. And then for distance between point A and charge 2, we also can calculate here by using theorem Pythagoras, where the distance between point A and Q2 is also equal to 5 meter. Okay? So, very easy. And then for the second point, you must remember that the question state that the magnitude of both charges Q1 and Q2 is equal magnitude. Magnitude-nya sama tetapi charge Q1 positive charge, charge Q2 is negative charge. Okay. So now we can try to resolve EA1. So look at the diagram. So we have EA1. So the blue arrow showing reservation for EA1X and EA1Y. Okay. And untuk EA2 pun kita boleh resolve kepada X and Y component. So we're going to have EA2X and EA2Y. Okay. Disebabkan jarak antara point A dan charge 1 sama dengan jarak antara point A dengan charge 2 dan dalam soalan ini kebetulan magnitude Q1 dan Q2 sama, jadi kita boleh cancel the Y component. Kita boleh cancel EA1Y dengan EA2Y. Kenapa? Sebab nilai EA1Y sama dengan nilai EA2Y, sebab nilai EA1Y sama dengan nilai EA2Y. Cuma yang membezakan adalah direction, di mana EA1Y is upward direction while EA2Y is downward direction. Okay, jadi kita boleh cancelkan untuk Y component. Jadi sekarang kita hanya tinggal X component sahaja. Okay, so we can try to solve electric field in X component. Boleh? Okay, but before we proceed for the calculation, make sure you calculate first what is the angle here between X component and EA1. Okay, so here saya dapat 36.9 degree and dekat sini pun samalah 36.9 degree. Okay, you boleh cuba kira. Alright, so now in order to calculate the resultant electric field at point A, so we consider X component only sebab Y component kita dah cancel tadi. Okay, sebab apa? Sebab dua point tu tadi. Sebab jarak antara point A dan charge 1 sama dengan jarak antara point A dengan charge 2. Dan kita boleh cancel hanya bila jarak antara satu point tu dengan Q1 sama dengan jarak antara point A dan charge yang satu lagi. Okay, dan kebetulan magnitude Q1 sama dengan Q2. Kalau magnitude Q1 dengan Q2 tak sama, kita tak boleh cancel ya for Y component macam itu sahaja. Kita perlu kira satu-satu. Okay, so in this case, we can consider X component only. So the net electric field at point A, we can write as EA1X plus EA2X. Okay, so EA1X is actually equal to EA1 cos 36.9 plus EA2 cos 36.9. Okay, so EA1 kita kena kira lah, where EA1 is the electric field due to charge 1. So gantikan dengan equation electric field KQ1 over RA1 squared cos 36.9 plus KQ2 over RA2 squared cos 36.9. Okay, so RA1 dan RA2 kita dah kira tadi 5 meter. So we can substitute dalam kita punya equation. And finally, the net electric field at point A, so betulkan kat situ EA sepatutnya is equal to 1.73 times 10 power of 3 Newton per Coulomb. Since the answer is positive, so the direction is to the right. Okay, so finish for the second part. So now we finish for discussion of electric field. So see you in the next video. Assalamualaikum dan selamat sejahtera. Bye-bye.